Hi, question in the PhD qualifying exam, University of Montreal, in October 2015. Let this one be a commutative diagram of additive abelian groups with exact rows. Suppose that F5 is injective, F2 and F4 are surjective. Prove that F3 is surjective. Let B3 be an element in the group B3. Let B4 equals to C3B3. Since F4 is surjective, there is an element A4 in the group A4, such that F4A4 equals B4. Then, by the commutation, F554A4 equals C4 C3B3. By the exactness, C4 C3 equals 0. So F554A4 equals 0. Since F5 is injective, 54A4 equals 0. This says A4 is in the kernel 54. By the exactness, A4 is in the image 53. This implies there is an element A3 in the group A3, such that 53A3 equals A4. Let B3 prime equals F3A3. By the commutation, we see that C3 E3 prime minus B3 equals 0. This implies B3 minus B3 prime is in the kernel C2. By the exactness, B3 minus B3 prime is in the image C2. This implies there is an element B2 in the group B2, such that B3 minus B3 prime equals C2 B2. This gives B3 equals F3A3 plus C2B2. Since F2 is surjective, there is an element A2 in the group A2, such that F2A2 equals B2. So B3 equals this one. By the commutation, B3 equals this one. Note that A3 plus Phi2A2 is in the group A3. So from this one, we see that B3 is in the image of F3. This proves F3 is surjective. Thanks for watching. Bye.